Greetings, Doctor. I'm Darshani Rajendran, S55538, and this is my presentation on individual assignment of research method in chemical sciences. The topic of my proposal for FYP is development of a molecularly imprinted polymer for endocrine disruptor, dibutyl phthalate. And I'm doing this study under the supervision of Associate Professor Chemist Dr. Faizatul Shimal Mahmood, and I've learned so many things in this journey of completing my assignments, to which I'm very grateful. Moving into my proposals, the first chapter would be on introduction. My introduction contains a few subtopics, the first one being molecularly imprinted polymers, MIPs, and its properties. MIPs are tailor-made synthetic materials with artificially generated recognition sites to be able to specifically rebind to a target compound. They operate by a lock and key mechanism to selectively bind the molecule which they were templated during the production. MIPs can be produced for almost any target molecule and is able to interact with respective templates with high selectivity. They are all about interaction between the template and the monomers to form cavity around the template molecule, and the template is removed, leaving the empty cavity behind for rebinding the target molecule. Next is 1.2, which is early MIP history. This is about a brief look into the history of MIPs and its evolution. 1.3 is about general considerations on molecularly imprinted technique. Main things to consider before imprinting is its template, monomer, cross-linker, and its solvent. Next up is 1.4, which is approaches in imprinting technology. There are basically three approaches in imprinting technology, which are covalent imprinting, non-covalent imprinting, and semi-covalent imprinting. Next up is 1.5, that is selectivity of MIPs. They also divided into categories which are characterization of selectivity and selectivity in various MIP applications. This is the part where explanation on selectivity is reported, where the common claim on MIP is that they are specific for their template on another targeted compound. This part is to justify the claim with demonstrations of experiments to prove the performance parameter of MIPs, to show effectiveness to its template. 1.6 is about endocrine disrupting chemicals, where EDCs are substances in environment that interferes with the endocrine system. It brings serious harms to human and animal health and also to the environment. To animals and humans, the effects of EDCs, which is endocrine disrupting chemicals, are often to reproductive functions that result in infertility, cancers, and direct effect to womb, whilst to the environment it has toxic effects. Scientists all over the world have been trying to develop methods to detect EDCs in the environmental samples over the past few years. The following subtopic would be dibutyl phthalate. This is the structure of DBP. It's a type of endocrine disrupting chemical used as plasticizer in different materials and etc. Its global production of phthalate ester is estimated at about 6 million tons per year and even more. It is used so much that it is one of the predominant phthalate esters present in atmospheric particles as well as it is in the fresh water and sediments. So it is important to innovate a method for the detection of EDC, so it can be said that molecularly imprinted technology is the most suitable way for rapid and cost-effective detection. Moving into my next subtopic, which is research objective. There are three objectives, which is to synthesize the dibutyl phthalate imprinted polymer by using non-covalent precipitation polymerization method for specific detection of endocrine disruptor, to characterize the adsorption properties of molecularly imprinting dibutyl phthalate by performing FTIR surface area analyzer, SEM-EDS, and ultraviolet visible spectrometry, to study the binding event of MIPs and NIPs, which is molecularly imprinting polymers and also non-imprinted polymers, on variables such as effect of time, effect of concentration, competitive binding study, and kinetic study. Next would be significance of research, which is I intend to develop efficient method to detect and remove endocrine disrupting dibutyl phthalate. I hope the finding of this study will benefit to society. I hope they contribute to the growth of science that will be extended to a wider and deeper development, as this study will serve as the basis of research on synthesis of dibutyl phthalate. To literature review, chapter 2. This part reviews previous researches done by others. I have reviewed 14 journals in total, but I'll only show 3 due to time restrictions. All of these researches were prepared for selective detection of dibutyl phthalate, and all 3 of these were prepared by precipitation polymerization, which is a non-covalent approach. Ozer and co-researchers made their MIP based on carboxyl modified silica nanoparticles with uh, N-methylcryloi-trifurfine methyl ester as the functional monomer, ADG-MA as the cross-linker agent, AIBN as the initiator, and the experiment was characterized by SEM, FTIR, and XPS analysis. Wolska and co-researchers prepared a pH-responsive MIP with MA and MMA as functional monomer, DVB as a cross-linking agent, and AIBN as the initiator. The MIPs were evaluated at various pH processes. Huang and co-researchers prepared a photo-control MIP based on magnetic core shell structure, MAPASA, as the functional monomer, and ethylene glycol dimethyl acrylate as the cross-linking agent, and silicon dioxide as the carrier. MIPs were also studied by various absorption studies. Chapter 3 is about methodology. 3.1 is about chemicals I used in the study, which are dibutyl phthalate, methachloric acid MAA, ethylene glycol methacrylate EDGMA, AIBN, toluene, acetone, methanol, and acetic acid. Next would be 3.2, which is apparatus and glassware needed and these are basically the apparatus and glassware that will be used in this study. Next up is 3.3, which is synthesis of molecularly imprinted polymers and non-imprinting polymers. This is the method to synthesis the MIPs and NIPs. It is via precipitation polymerization modified based on procedures in Fauzia et al. 2021. Next up is 3.4, which is adsorption study. In here, what parameter and how it will be discussed is explained. MIPs will be characterized based on effect of time on absorption ability of MIP, effect of concentration of MIP, absorption ability, binding capacity of MIP and NIP, kinetic study of MIP and NIP. Finally, we are at chapter 4, which is expected results. The MIPs and NIPs will be obtained in the form of granules or beads. Under the SEM analysis, images of the surface morphology of NIPs before and after extraction should contain grains that appear as cores with irregular sizes and joined to one another. The SEM images of the surface morphology of MIPs before and after extraction should show granules that appear smooth with regular sizes and that does not blend with each other. The FTIR spectrum of prepared beads should be observed that OH functional group in both MIPs before and after extraction should not have a significant shift. However, a stronger intensity must be observed for MIPs after extraction compared to MIPs before extraction. This is due to breaking of OH functional groups on molecules. No shift in the wave number of carbon-carbon bond will be observed. The intensity of carbon-carbon bond in NIP and NIPs must be weaker than MAA monomer. This is because breaking of the double bond by the initiator through a polymerization reaction on the monomer and cross-linker, and this affects the formation of NIP and NIPs. Lastly, the optimum time needed to adsorb dibutyl phthalate by NIP should be around 60 minutes, which will be 1.1746 mg per gram of adsorbed DBP. Thank you. That's all from me. Thank you for your time.